So heterogeneous equilibrium. You couldn't find your GMP, now I have to make up shit then. Okay. Okay. Let's see. A solid is going to be equal to B gas plus C gas. Yeah, let's continue. So let's say I'm going to be having A solid is going to be equal to B gas and C gas. Let's say we have B solid is in equilibrium with C gas and E solid. And let's say I'm going to be having, okay. Honestly, it's been a while since I've made questions of this sort. I'm a little rusty. So yeah, I'll add the pieces as and when we get there. So let's say I'm going to be having first guy here, having Kp being say equal to 8. And this guy Kp is supposed to be equal to 3. What will happen if I take A solid alone in container?
B gas and C gas would form.
B and C gas will form. How much of each?
Yeah.
What are the pressures?
4 and 4.
4 and 4. Wonderful. Now, let us say second case is taken now. In this case here, I am going to be taking A solid first into container. Then after some time, I'm going to be adding D solid. What happens now?
Then initially only B and C would be there and some A. And
So
then
initially we end up having B gas and C gas, and they will be at 4 atm and 4 atm. Correct?
yeah.
So when I add the D, what is supposed to happen? What's the issue here? I'm supposed to have C gas plus E solid form. Correct? But what is my partial pressure of C gas now?
It'll be 4, already 4.
Already 4. So if it is already 4 here, will I have D dissociating?
No, not much.
Be very specific with terminology. Don't give me messed up terminology. This is not chemistry we are discussing. This is math we are discussing now. So be specific. Will
No.
D dissociate?
No.
Yes or no? No. Why? Because this is already 4 atm.
Yes.
This is already something where the Q for
Is
the
much greater than
is greater than the K equilibrium for the
Yes.
second equation.
Hmm.
So there will be no chance of D dissociating over here. Okay. Now my third question here. I'm going to take D solid in a container first. Then wait some time. Then add A solid. What happens now?
Initially the C and E gas will be present with 1.5 pressure.
Is E a gas?
Oh, sorry. Oh, my bad. Only 3 atmospheres. The C will have 3 atmosphere partial pressure, and once the A is added,
What will happen?
The A will dissociate.
The A will dissociate. Okay, all right. So if the A dissociates, what will happen?
That means Q is less than K equilibrium. That means more C will form. More B and C will form. That means D will become.
You get your question now as to where it is going to be going.
Yeah. Yes.
So start. Think. What will happen now? You have a half a minute to 1 minute to think it out and try it out for yourself. I'll of course give you the answer as to what is going to be happening as well. You try it though.
Okay, sir.
My question here is, what is my final state look like?
The good number. No.
Hmm?
With the numbers and all.
Whatever you can give me, I'll take.
Okay.
Now, this is just a baby level question, by the way. Okay, let's directly go into it. You have an answer? Do you have a pathway to the answer?
Right. Just following the steps, like what will happen, like after,
Explain. So,
like, okay, when you add the A solid,
Mhm.
the pressure of C gas is already 3 atmospheres,
Mhm.
and it would want to make it
That
more.
becoming some X.
Yes.
This will become 3
4.
plus X.
Sorry. X, yeah.
Right. And this 3 plus X, this 3 plus X, let's say it reaches equilibrium finally. Some value.
Yes.
Problem
Yeah.
is now this is also 3 plus X.
Then this also becomes 3 plus X, yeah.
Then what will happen now?
Then,
Is this at equilibrium? No, let's call this equation 1, let's call this equation 2.
2 is not equilibrium then. No.
What will happen now then?
Then more D will be formed.
How?
It will not decompose.
Consume the E
Sorry.
which is already produced.
Sir?
There was some E which was produced here, no? In
Yes,
the
yes.
essence, when I added the
Huh.
D solid first, there was some E produced.
Correct, yeah.
So it consumes that E and it becomes D.
Yeah.
Correct? Till when?
Yes.
Till it reaches.
Till it becomes 3, yeah.
Okay, then now this is 3. This is a X right now.
Yeah.
Originally X into 3 plus X was whatever it was, equilibrium. Now it is again this now. So this will become X
Yeah.
plus Y. This will become 3 plus Y.
Hmm.
This will again become 3 eventually. This guy will do its thing. It will keep doing its thing till when? Till when can the second reaction keep doing its backward direction? Is there a limit for the backward direction of second reaction? I did not add any E solid in the beginning, no?
Yeah.
What did I add first? I added only D.
Only D, yes.
I didn't add E.
Yeah.
So when I did not add E and I only added D here, what will be happening here? Till the E solid is present from the original decomposition.
It will still be going backward.
It will
At
keep
least
going
some
back.
amount. Yes. Yeah.
When will
Until that
stop
gets
then?
consumed.
Until
E
the
gets
solid
consumed.
is fully consumed, it will keep going. But after it's fully consumed, it stops.
Until the E solid, you said?
Yes, until the E solid.
Yeah. Okay, yeah. Yes.
So what will be the final state right now then? Full D?
C will be at some 3.
No, not 3. There will be full D. No E.
No, C I'm saying.
C. Let's not think about C now. Let's think about the D and E first.
D will be full, E will be 0.
D will be full, E will be 0.
Hmm.
What does that mean?
It means forward reaction.
No, that means that's the same as this shit.
Oh, yeah. Correct, yes.
You understand the idea here?
Yes.
So
Yeah.
that's the same as the second case actually. That means, what is my C?
4 atmospheres.
You understand the principle here?
Okay.
To some extent, you're having a clear idea how things can play around over here, how complicated shit can get over here. I'll give you one more scenario here. As I said, this is just a baby level question. Things can get very interesting. Let's say I'm having A solid and E solid. And A solid is in excess. Let me make another case here. A solid, E solid. Let's say E solid is in excess. Let's try case 5 first. What happens there? I'm going to have A solid first in the container. Let's take this guy first. Or it doesn't matter. Take both in the container at the same time. What happens?
E will be in excess, so D will not dissociate, and then so lesser C will.
Stop. You're bullshitting here. When you're given a question, dissociate yourself from the previous crap. Stop your crappy assumptions from the previous question now. That is not the same as this. Stop it. You're making assumptions here. Put down pen to paper and try writing it down. A first is there along with E solid in excess. If A is there first, what is going to be happening? Go step by step. These are not easy questions to be directly, bluntly like bulldoze through and assume you'll get the correct answer. You have to finesse your way through these questions. If you're not going in the correct path here, you will get funny answers or you'll get unexpected shit as answers. So first, A solid is going to produce B gas and C gas.
B gas and C gas.
Each. Now, I do not have any D solid in the beginning.
Yes.
But I have C gas and I have E solid.
Yes.
So, this equilibrium straight away applies right now. So, this was 4 now, correct?
Yes. Yeah.
But what is the equilibrium constant for this guy here? 3.
3.
What should happen?
Want to make it?
It'll go in back.
This should backward direction, exactly. Yeah.
So, if this goes in backward, D gets produced. Okay, all right. This will go down to 3 then. What will happen then? If it goes down to 3, what will happen?
In the first reaction.
Well, again, this will also go back to 3 then.
Yes.
That means this will increase now. It will become 4 plus x. This will become 3 plus x.
Yes.
Correct?
Yes.
Then this will be 3 plus x then. This 3 would have then changed into 3 plus x.
Yeah.
Which will then change back into 3 again.
Yes. So this will also again change to 3 and 3 plus x.
Good. So finally what will happen? This will remain at 3 only. This will be at some 4 plus x, where this is going to be 4 plus x into 3 will now be equal to my 8. See,
8.
What not 8? What, sorry. Oh, fuck. I said KP is 8. Yeah, Chutia I was. Oh, we are both assholes. We are both useless idiots. How shitty are our calculations, my friend? Oh, crap. I should undo. Do you see the mistake we have made? I have made. And you have made as well.
It's too low.
You understand the mistake there or not? No.
The KP value was too low. But
No, it was 8 and we did 4 and 4. We should have done root 8 and root 8.
Oh yeah. Oh yes, yes, yes. Oh yeah.
Oh God. Because everywhere I put 4 and 4, I got lazy. I decided I'll change the easiest one to change out now.
Yeah. Correct.
Okay, fair enough. So in this case here, 4 plus x into 3 should be equal to 16.
16. Yes.
So solve for x. Or solve for 4 plus x. So obviously 4 plus x is how much over here? That is going to be
16
the
by
B
3.
gas. So partial pressure of B will work out as 16 by 3. And partial pressure of C will be 3. If I have excess E. If I have excess A, nothing happens. Same as this.
Sir, why would the C gas go to 3 again?
Hmm?
Like finally, why would the C gas go to 3?
Why would the C gas go to 3? Because you want equilibrium finally, correct? What does equilibrium mean? Every reaction which can be at equilibrium should be in equilibrium.
But the first reaction is not in equilibrium, right?
How is that not an equilibrium? If I have partial pressure of B gas as 16 by 3 and I have partial pressure of C as 6 as 3, how is that not an equilibrium?
Oh yeah, correct. Oh, so this B will vary itself. Okay.
Yes, B will vary itself to adjust according to what the C is going to be requiring.
Okay.
So in this here, this fourth case is the same as the fifth case actually. There will be a new case though. That new case will be very limited E. E solid plus A solid. In that case, we will have something interesting happening. We may not ever reach this backward direction sufficiently. So the second equation may not ever reach equilibrium at all in that case. If I have very limited E and what to say, a reasonably large amount of A, that will become similar to this case. A solid first and then D is added. I think I am losing your head over here already.
No, I understood.
So these are what to say. This is a very simple model then, where you're going to be having heterogeneous equilibria, where I've just played with 2 equations, nothing else. You can obviously play with 3 or with 4. Where you're not going to be having just what to say one interrelated set, you can have like 2 or 3 interrelated set of solids. And when you're having multiple interrelated solids, you have to really think how shit is going to happen. And in some cases, there will be a clear difference between when you have, say, A first and then added D, or D first and then added A.
Yes, sir.
You understand the principles over here to an extent? Obviously, as of now, we don't need to really touch up into this in detail because I'm just starting to realize the current batch, the reason why the syllabus has been changed so much is because they are a COVID hit batch. They are the COVID hit batch. The complete COVID hit batch at that time. So effectively, their entire 9th and 10th was messed up. And they could not understand shit in 11th and 12th. But I think you are the batch from where COVID did not affect beyond a point. You guys were in COVID in 7th and 8th standard, correct?
Yes, sir. Yeah.
So,
and partially 9th.
Yeah. When you were in 9th, you were already in like proper, what to say, just end of COVID, where everything was already like streamlined. Proper work was happening even during COVID time, I suppose.
Yeah. Half of the year was online. Yeah.
Sorry?
Half of the year was online, other half was
Half
offline.
of the year was online in 9th standard. So you guys are also actually technically a COVID hit batch then to some extent.
Kind of, yeah.
9th standard is a very foundational year. If that is hit badly, yeah, that will really mess up the entire thing. And that's why this year there is much more relaxation in the syllabus at least. I'm not sure how long it will continue on for. Dekhte. And so if you want more questions of this type, I'll have to sit and make them. You can say questions get quite complicated. I'll have to think a little bit more. You can find them in books. Really good.
I'll try to search for the GMP.
Huh?
I'll try to search for the GMP. Yeah.
GMP will have. And if your friend has some, you have an elder brother, right?
Yeah, he wasn't in Fiji.
Did Fiji?
No.
Okay. Your friends will have some elder brothers who have done Fiji shit. They'll have AITS papers.
Yeah, I have AITS papers.
AITS papers में होगा. They'll have these
I
kind.
couldn't find any. I was searching for a few ionic equilibrium questions. I couldn't find any of these.
Yeah, these are like very rare AITS papers where the teacher really wants to mess with the student. They will ask funny questions. AITS normally अच्छा तो होता है यार AITS papers. Quality
I didn't see. Yeah.
Okay, so the questions all seem standard only in AITS also.
Yeah. I mean, yeah. But they're tricky. The kind of.
I get the point. All right. Then what else is done? So far, then we are done with what we wanted to discuss more or less. Solubility product. Are you sure you are clear with the topic over there?
Yes, sir. I
No
think I'm
problem.
clear to an extent. Yeah.
You've really learned unfortunate things from me. Diplomatic speak.
Diploma.
Making sure nothing is like completely told. I'm reasonably confident nearly. Anyway, what else is happening right now in your school? What are the other topics? Anything else which we had left to discuss?
I don't think anything was.